Hello everyone, I am Dr. Thrimurthulu, professor in Department of CSC, MLR IT, and my subject is Introduction to Artificial Intelligence. In that, this is the 6th video, and today's topic is Uninformed Search Algorithms description. Coming to the overview. So, in this uninformed search algorithms, what it is, and last class we have discussed one of the algorithm, that is breadth first search algorithm. Now today I am going to discuss depth first search, after that depth bounded first search, iterated depth first search, uniform cost search, and advantages, disadvantages of those things, and comparison of breadth first search and depth first search. These are the topics I am going to cover now. And coming to the, as for MLR IT R22 regulation syllabus, and now I am in these are the topics, end of the first unit topics I am going to discuss today. And coming to the next, so last class we have discussed what are the different types of algorithms. In AA there are the two kind of algorithms, uninformed search and informed search. In uninformed search there are the depth first search, breadth first search, and uniform cost search. In depth first search again there are the variants are there, and today class we are going to discuss these uninformed search algorithms. And coming to the one of the depth first search, this is the one of the uninformed search algorithm, and one of the blind search algorithm. You are blindly systematic way you are following that one, and it is a transversing graph algorithm. It is a transversing graph tree algorithm, and it starts from the root node, and in depth it is going one by one, and till there is no till it is exhausting, then only it is backtracking to the next depth level, so that it is all the levels it is visiting at a time in that depth level. So it starts from the root node, like this, and coming to the, suppose this is the first node A, then again it is generating the other child nodes, evaluating the child nodes, and it is going to the B node to C node, D node to again E node, then it is coming back to the again parent node, like that way. Then again coming to here and coming back to here, like this, again it is coming to the from the starting node to another depth level, depth level H, then it is coming to the high, then coming to the K. In between, if the goal is reached, suppose, then it is terminating that algorithm. So DFS is the one of the depth related algorithm, complete depth till it is exhausting, then only it is coming, it is written back to the parent node, then it is taking the another depth level. So it is uses the stock based data structure. This is the stock based data structure, like a LIPO, last in first out, it is operations, and it is a stock based algorithm, stock based data structure, that is. And when it comes to the algorithm, we are initializing the goal state. Suppose S is the goal state, first we are initializing the goal state, then we are comparing that one, whether it is the initial state itself is S is the initial state, G is the goal state, this is the initial state. Then we are starting with the initial state, then we are comparing whether the initial state itself is the goal state. If not, the algorithm will run, it is going to the next level, it is going to the A, then it is finding whether it is the goal or not, otherwise again it is evaluating their child nodes, successive nodes, then it is coming to the like B node, and it is comparing with that, then again it is going to the depth node, there is no further nodes in that, it is adjusted in that depth, then again it is coming to the next child level, then coming back to the next child level parent node, like this. It is recursively it is going backtracking to the next depth level. So this is the algorithm. Initial goal it is initializing, and it is, if it is the same means return the success, otherwise the loop will continue, generate the say evaluating node E, then let it be successor of the initial state. If it is the successor of the initial state, there are no more successors, means it is giving the return failure, otherwise it is continuing, it is evaluating the successive nodes, then it is checking with that whether it is the goal node or not. If the success is returned, then signal is success. Otherwise, continuing this loop, it is going to the next depth level. Next depth level, like this, it is coming. So this is the depth first search. Okay. So the pseudocode for the depth first search is the here it is the stock is empty. Initially, it is the stock based data structure. Stock is empty. Here and whatever the visited nodes are initially it is the empty. You are keeping and stock dot push whenever you are visiting you are keeping into the stock that. So here while not stock is empty, then current stock it is going to the stock, and if the current is goal, then return the path found. Otherwise, the loop is continuously it is going. It is visiting the another successive nodes, and that information, that fringe information, we are keeping in the stock, and whatever the information that is the last in, first out, last whatever you are entering, suppose that again return first it is exiting, then it is coming back to next, coming back to next, coming back to next, then coming to like this way. It is depth first search algorithm. It will run like this. This is the pseudocode for the depth first search. Then coming to the another variant of the depth first. This is the what are the advantages in this case. So it occupies the very less memory. That is the one thing advantage. And it only needs to store the stock of the nodes on the path from root node to the root node. This is the root node to the current node. That information you are keeping in the stock. So that information only it stores. That's why it takes a very less memory. It takes less time to reach to the goal node than the depth first search. If it is the in this level itself means immediately you are reaching to the goal node. So this is the depth first search. Disadvantages is there is the possibility that many states keep reoccurring and there is no guarantee of finding the solution. If the first depth level, if we are going, there is no solution means again going to the next depth level. If it is the solution is not there means maybe sometimes if it is the large set means we may not get the solution. If it is the small data sets, we will get the solution in these cases. Deepest algorithm goes for deep down searching, and sometimes it may go to the infinite loop. If it is in this depth level, if it is the infinite loops are there means infinite nodes are there means it takes a lot of time. There itself it takes. If suppose the next depth level immediately near to next depth level, suppose goal is there means you have to reach this all entire infinite loops, then only it is coming back to the next depth level. So that that is the drawback in this case. It takes a lot of time. Time complexity is more, and sometimes we may not reach the goal. We may not get the solution because of if it is the large number of loops are there, nodes are there. Okay, in that cases. So suppose this is the one of the problem. Suppose this is the problem state. S, A, B, C, G, these are the problem state. For this case, okay, this is the problem. For this problem, I am solving this one. See, this is the graph based tree for these cases. S, then S is going to the A, then A is going to the B, B is going to the C, C, and again B as a loop is there, G, and here also C also it is a goal is there, G. And next it is the another way connection is there, D and D to G. This is the graph based for this problem. Then initially it is the depth first search, so that it is taking the root node, then it is checking whether it is the goal node or not, then it is coming to here, then coming to the next goal node, checking every node it is checking, then coming to here. Now we got the, suppose G is the goal node, so it is exiting there and it is giving the root path S to A, A to B, B to C, C to G, like this it is giving. This is the path for this problem. Then coming to the depth first search complexity of it is. So it is the LIPO based order. The data structure is last in first out cases, and it is the stock based data structure. That is another thing. And whatever the time complexity is O into BD, the branch number of branches it is branch levels, then number of nodes you have visited connections, end connections. So that depending on the operation is B into D. Okay. Even time complexity also it is the same thing in these cases. Can find the long solutions quickly if lucky, a short solution slowly if unlucky. in these cases. This is the time complexity for that case. And coming to the another variant in this case, depth bounded first search. That is also you are called as a depth limited first search. Whereas previous depth first search, we are listing all the nodes till exhausting. So that what happened with the large data sets in depth, the large nodes in itself in the depth, it takes a lot of time. So that we are keeping the some limitation in this case. This is the somewhat advantage. Yeah, a limitation is there, so that we are going backtracking to the immediate parent node and taking the another depth level. So here see, depth limited first search. This is the one of the. This is also called as a depth bounded search, and it is the modified version of the depth first search that imposes the limit on the depth of the search, how much level you have to go. There is the limitation is there. So this means that the algorithm will only explore nodes up to certain depth only, and effectively preventing it from going down excessively deep paths that are unlikely to lead to the goal. Suppose in the depth level, if it is the goal is there, means you are unlucky, you are not getting the completeness. So that is the problem is there. But suppose if it is the near to the root node itself, the other depth level starting itself, if it is the goal is there, means that is the lucky you are getting immediately, because the first depth level you are going down and again coming back to the parent node and taking the another depth level. That is starting itself, it is the goal node is there, means you are getting so immediate goal you are getting. So sometimes it is the fast, the depending on the problem. Okay. By setting the maximum depth limit, DLS aims to improve efficiency and ensure more manageable search times. That is the advantage in this case, because it is improving the efficiency levels and ensure the manageable search times, because your limitation is there, that depth level only you are going to search and again coming back. So how depth limited search will work? So starting we are initializing the things, begin at the root node with the specified depth limit. We are limit whatever the limit is. If it is the 3, means 3 depth levels only you are going, then we are coming back, the depending on the depth limiting parameter. So then exploration transfers the tree graph, exploring each node's child nodes. Then depth check, whether it is the limit is we are crossed or not, we are checking depth check, that is the depth level, how much it is. If the current depth exceeds the set limit, stop exploring that path and backtrack to the parent node. So then every time it is the goal check. If the goal node is found within the depth limit, the search is successful. The search is successful, that is goal check. The another one is the backtracking. If the searcher reaches the depth limit, maximum limit, or leap node without finding the goal, backtrack and explore other branches, exploring the other branches. This is the process how the depth limited search will work. The another variant is the depth first iterative deepening. Depth first iterative deepening, that also called as iterative deepening depth first search algorithm. This is the another extension of the depth first search algorithm. Iteratively it is moving, and same combination iteratively every time we have the depth limit is increasing. So DFID is a combination of DFS and BFS algorithms, both the combination, depth first search and breadth first search algorithms combination, that is depth first iterative deepening algorithm. This search algorithm finds out the best depth limit and does it by gradually increasing the limit until the goal is found, so that the depth level you are increasing gradually. This algorithm performs a depth first search up to certain depth limit, and it keeps increasing the depth limit after each iteration and until the goal node is found. There is the depth bounded search if the boundary is there. If it is the boundary is exceeding, means you are backtracking to them. Here it is not there. Then you are changing the limit level. This search algorithm combines the benefits of breadth first search, that is called as a fast search, and a depth first search memory efficiency, because the breadth first search is the fast search algorithm, that is the advantage in that case, whereas the depth first search is the memory efficiency algorithm. These two advantages this algorithm has. So it is the combination of both the things. That's why it is the memory efficiency is good, and the it is the fast search also it is possible in this algorithm. So what are the advantages in this case? Uh, the iterative search algorithm is useful uninformed search when search space is large cases. The depth goal node is unknown and depth of the goal is unknown. These cases you can use your depth first search algorithm. Advantages: it combines the benefits of both the breadth first search and depth first search algorithms in terms of fast search, whereas breadth first search is the fast search algorithm and depth first search is the memory efficiency algorithm. Both the combination advantages are there. What are the disadvantages in this case? Means repeats all the work of the previous phase, because iteratively it is moving to the next levels, and next depth level also you are going. The depth level also you are increasing gradually. If you are not getting the goal. So that what happens, more nodes here, and you are repeating the nodes. You are repeating the same nodes. So these are the drawbacks in this case, and this algorithm is how it is that this algorithm pseudocode is here. It is a search strategy resulting when combine the both the cases already are discussed. Thus combining the advantages of each strategy, taking the it is giving the completeness, that is the one good advantage in this case, and the optimality of BFS and the modest memory requirements of the DFS, both the advantages this algorithm has. And ideas works by looking for the best search depth D. So that is the depending on the depth limit initial. Thus starting with the depth limit 0 and make a breadth first search, then you are going to the breadth first search, then you are taking the deepening to the in the depth first search. And if the search failed, it increase the depth limit by 1 and try BFS again, and with the depth 1 and so on, it is going on increasing gradually. The depth limit is initially it is the 0, then 1, then 2, and breadth, then depth level it is, then breadth level you are visiting, then again depth level is increasing further and you are finding the goal. Then 1 and 2 and so on until depth D is reached where the goal is found. Till goal is found, we are increasing gradually this depth limit, that is the iterative deepening depth first search algorithm. So the algorithm is here procedure for depth time. Depth is from initially it is the 0 to infinite, and found DLS root and depth root we are defining, and depth we are initially are giving, and if found null return found. And if procedure is DLS node, again node it is identifying the which node and what is the depth level it is identifying. And if the depth is 0 and node is a goal, then return node, you are success, you are getting the solution. Else if depth greater than 0, for each child node found DLS child depth minus 1. If found null, otherwise return found, return null if you are not getting the solution. So gradually you are increasing 0, 1, 2, 3 till infinite you are going to this same depth first search level. It is both the combinations it is going on, breadth first search and depth first search. So another variant is the uniform cost search in uninformed search algorithm. This is one of the uninformed search algorithm, and it is different from the previous cases, breadth first search and depth first search, because here the cost factor is important. Based on the cost factor, it is going either breadth level or depth level. So here the cost come into play. In other words, transversing via different edges might not have the same cost. So the goal is to find the path, that is the one thing where cumulative sum of the cost is least cost path it is finding to reach the goal. So cost node is called cumulative cost of the all nodes from the root, whatever you are listing. Cost root initially it is the 0. Then this is the only cost based algorithm, so that so with the small cost you are reaching the goal. So shortest path you can find out in these cases. Uniform cost search is complete, you are getting the complete solution, that is the one thing. Its states are finite, if it is the limited only finite, and there should be no loop with the 0 weight, then condition only it is working. UCS uniform cost search is optimal only if there is no negative cost. Whatever the node cost is there, there is no negative cost, then it is giving the optimal solution. So that is the advantages in this case. Shortest path finding and optimal path finding also it is possible. That is the one. Disadvantages. Explores the options in every direction because it is going either breadth level or depth level. Both the cases it is going on uniform cost search. Whatever it is there, nodes, and it is based on the cost factor. If it is a 1, 3, 5, suppose 6, 2, 0, suppose like this it is there. So this is the goal node suppose. So it initially it is taking here, then taking this path and taking this path. Like that way overall cost it is the 1 plus 3 plus 2 plus 0, it is the 6 only cost. So that this is the route. Whereas these routes suppose this is 4, this is the 5, like this suppose it is there. And goal node is also it is reaching suppose like this. And overall cost what happens here, 5 plus 4 plus again this 9, its cost is the 9, this route cost is the 9. So that shortest cost it is finding. That is the advantage in this case. And what are the differences between the breadth first search and the depth first search? These are the main categories in uninformed search algorithm. So BFS stands for the breadth first search, that is the level based algorithm. DFS stands for the depth first search algorithm. This is the vertical it is going on in depth. That is the, and coming to the data structure of it is. So breadth first search uses the queue data, queue based system, queue data structure that is, and the first in first out that is the operation is. And whereas depth first search is the stock data structure this is. And coming to the definition of the breadth first search, it is the transversal approach which we first walk through all the nodes on the same level, the same breadth level. We are visiting all the nodes before moving to the next breadth level. That is the thing. Whereas this one DFS also it is also transversal approach in which the transfers begin at the root node and proceeds through the nodes as far as possible until we reach the node. There is no unvisited nearby nodes in that case. Till depth level complete exhaustiveness we are reaching, then only we are backtracking to the parent node and taking the another depth level. So conceptual difference what it is means, both builds the tree level by level, it builds the tree subtree by subtree level. Tree level by level it is the level based algorithm, it is the subtree and by subtree level algorithm. And the approach used in this case is it works on the concept of first in first out. First in first out like that, this is the breadth first search. It works on the concept of last in first out. That is the approach it is following, that whatever the memory fringe. And suitable for BFPs is more suitable for searching vertices closer to the given source. Suppose if the goal node is closer to the source node means this is the best suitable for that cases. DFS is more suitable when there are solutions away from the source. If the goal node is root node, if it is nearby the root node means BFS is the best. But the goal node is far away from the root node means DFS is the best one. And what are the applications? BFS is used in various applications such as bipartite graphs, shortest path finding purpose. If we wait every edge is same, then BFS gives the shortest path from source to every other vertex. That is that. Whereas DFX is used in various applications such as acyclic graphs, finding strongly connected components in a binary search algorithm. And there may be applications, both BFS and DFS can be used like topological sorting and cycle detection, sorting purpose, binary search purpose. This is useful DFS algorithm. And one of the problems, suppose robotic path finding, this is the initial condition, the problem condition initially is like this. Suppose this is the maze 6x6 maze, 6x6 maze, suppose maze dimension is the 6x6 and this is the initial state. Suppose this is the initial state condition robot, it has to reach to the goal here from the starting node to goal node it has to reach. So the depth first search how it is working here, see we are defining the maze size 6 and whatever the obstacles also you are defining in the algorithm. Suppose this is the 0, 1, 2, 3, 4, 5, total 6, 0, 1, 2, 3, 4, 5, so that each location, what it is, location you can identify it. Here the obstacles are there, whatever these are the obstacles, all these are the obstacles. You have defined the obstacles in 0th row and 1 position. So 0, 1 obstacle is there, 1, 1 obstacle is there, 3, 2 obstacle is there. This is the 3, 2, 3, 3 obstacle, and then 3, 4 obstacle, 3, 5 obstacle. Like this, you have defined all the obstacles, and you are initializing the thing. The starting state is the 0, 0 is the starting state, and you have reached the goal. It is the goal node you are defined. That is the 0, 5. So the algorithm will run based on that. So this is the way the path, robotic path, it is moving. Initially, it is the obstacles are there, so that it not taking the depth. That's why initially it is going like this. Next level, then next level. Again it is coming down and coming to the this level, and depth level it is going. It is reaching to the goal node. It is reaching all these nodes and coming back to the goal node you have reached. This is the robotic one of the solution for the robot path finding. And today's video I covered uninformed search algorithm. What are the types? Already last class covered, and again, and depth first search in detail you have described that one, and depth in that the variance of the depth first search is the depth bound or depth limited search also I have discussed in this, and further extension of the depth first search, that is the iterated deepening depth first search also I have discussed, and another model of the uninformed search algorithm, uniform cost. It is the cost based algorithm, only cost only it is finding, a cost based algorithm it is, that also I have discussed, and advantages disadvantages of the depth first search variance also I have discussed in this video, and comparison of the breadth first search and depth first search. These are the things I have covered to today's topic, and any queries please mail me. My mail ID is Thrimurthulu, thrimurthulu.v@mlritac.in. That is the mail ID. And next video I am going to cover informed search algorithms. In this, what is the heuristic function? Because informed search algorithms also called as the heuristic search algorithms. What is the function I have discussed. Then one of the informed search algorithm I will discuss in next video, best first search algorithm, and their advantages and algorithm. I will discuss these things next video.